Hello everyone, I am Dr. P.S.V.Shanmukhi, Associate Professor, Department of Physics, Aditya University. Now I am going to explain about the Fermi-Dirac distribution function. This is also called as FD law simply. At the end of this lecture, student will able to understand the distribution of free electrons among various energy levels, and you can also know the variation of distribution function with the temperature. So, okay, coming to the Fermi-Dirac distribution function, actually in a free means in a metal there exist so many valence electrons. Actually, as per the free electron theory, these valence electrons are free to move randomly. Suppose this is a metal containing the so many free electrons like this. Now my target is to distribute these free electrons among various energy levels. How to distribute the free electrons? One thing, we know in an atom how to distribute the electrons as per the electron configuration, means 1s2, 2s2, 2p6 like that. But to distribute these free electrons among various energy levels, so there are some laws. Out of them, best one is the Fermi-Dirac distribution function. The distribution of free electrons among various energy levels is led by Fermi-Dirac distribution function, or simply called as FD law. Suppose as per this FD law, say these are different energy levels. Every energy level can be occupied by maximum 2 electrons. One is clockwise spinning electron, second one is anti-clockwise spinning electron. Anyhow, this distribution is given by FD law. It is a mathematical expression given by f of e is equal to 1 by 1 plus e power e minus ef by kt. So, this is called FD law. That mathematical expression is called FD law. In this one, as usual, K is the Boltzmann's constant, T is the absolute temperature, EF is called the Fermi energy level or simply Fermi level. F of E is called, it is the probability of finding the electrons. F of E is the probability of finding the electrons. Coming again, the distribution of free electrons among various energy levels is led by FD law. That FD law is a mathematical expression given by f of E is equal to 1 by 1 plus exponential e minus ef by kt. Exponential means e power. So, in this one, K Boltzmann's constant, T absolute temperature, EF is called the Fermi energy level. One by one term let us discuss. F of E is called probability of finding the electrons. Probability generally takes the values from 0 to 1. If f of E is equal to 0, the given energy level is said to be empty. If f of E is equal to 1, the energy level is said to be completely filled by the electrons. Completely means 2 electrons. One is the clockwise spinning electron, second one is anti-clockwise spinning electron. If f of E is equal to half, 0.5, it is said to be half filled, means the given energy level is filled by only 1 electron. That means f of E is representing probability of finding the electrons in the given energy level. So, it takes the values from 0 to 1. Okay. K as usual Boltzmann's constant, T absolute temperature. Coming to EF, the most important parameter EF. EF is called the Fermi energy level. So, how do we define the Fermi energy level? Actually, at T is equal to 0 K, definitions are there for the Fermi energy level. Actually, it is a reference line with reference to which other energy levels can be located. It is a reference line. So, if you want to talk about the metals or semiconductors or insulators, always all the energy levels are expressed in terms of the Fermi energy level only. It is a reference line. Coming to metals, at T is equal to 0 K, the uppermost filled energy level is called Fermi energy level, below which all the energy levels are completely filled, above which all the energy levels are empty. At T is equal to 0 K, we have to specify. Same, once again, Fermi energy level is the uppermost filled energy level, above which all the energy levels are empty, below which all the energy levels are completely filled by the electrons. In metals, at T is equal to 0 K, we have to specify 0 K, other than 0 K it changes, other than metal again changes. This is the definition in metals at T is equal to 0 K. So coming to the graphical representation, f of e values are taken on the x-axis and energy is taken on the y-axis. F of e is actually the probability, it takes the values from 0 to 1. Now up to EF, what is f of e? F of e is equal to 1. Above EF, what is f of e? F of e is equal to 0. So above e greater than EF, f of e is equal to 0. E less than EF, f of e is equal to 1. If at e is equal to EF, f of e is equal to 0.5 other than 0k. That what we have to mention. I will tell you that. Actually, suppose as the temperature is increasing, what happens? When the temperature is increasing, electrons will go to the higher energy levels. As the electrons are going to higher energy level, probability for the higher energy levels increases above the Fermi level, probability for the energy levels below the Fermi level decreases. You observe probability is increasing and for these energy levels probability is decreasing. So we get a graph curve like this. Suppose this is at any temperature, say 300 degree Kelvin. Suppose at any particular temperature T1, maybe 300, 500, 1000, 1200, whatever the temperature, at a particular temperature you will get one probability graph. Again you increase the temperature, what happens? By increasing the temperature, again from the higher energy level, from the lower energy level, again the electrons will go to the higher energy level. Means again at very higher energy levels also probability increases from 0 to certain value. Below the Fermi level, lower and lower energy levels you go, probability decreases from 1 to certain value. So that means as the temperature is increasing, different probability curves we get at T1, T2, T3, so on we get. But irrespective of temperature, you take f of e is equal to 0.5. Suppose f of e is equal to, what is the equation? 1 by f of e is equal to 1 by 1 plus e power. Suppose I want to take e is equal to ef, e minus f is 0 by kt. Any temperature you take 0 by kt, it is 0. So 1 by 1 plus e power 0, you will get say 1. So it is equal to 1 by 2 or it is 0.5 irrespective of temperature, but other than 0k, f of e value is 0.5. That energy level is called Fermi energy level. I am giving another definition for the Fermi level. The energy level at which probability of finding the electrons is 0.5 irrespective of temperature, but other than 0k in metals. Again I am specifying in metals. So like that Fermi energy level, so these are the probability curves. Different probability curves we are getting at different temperatures, but all are passing through a single point, say C, that is called crossover point. At this crossover point, f of e is equal to 0.5. This is the variation of Fermi energy level with the temperature. So coming to the summary of this one, actually we have seen the distribution of free electrons among various energy levels. Actually every metal is containing large number of free electrons. These electrons are distributed by FD law, Fermi Dirac distribution law, that is given by f of e is equal to 1 by 1 plus e power e minus ef by kt. So as per this one, the electrons are distributed, uppermost field energy level is denoted by EF Fermi energy level, and below that all the energy levels are completely filled, above that all the energy levels are completely empty. And as the temperature is increasing, electrons will go to the higher energy levels from the lower energy levels. Therefore, above the Fermi level, f of e is increasing from 0 to certain value. Below the Fermi level, f of e is decreasing from 1 to certain value. But irrespective of temperature, f of e is equal to 0.5, but other than 0k in metals. Like that, another definition we have given. This is the variation of distribution function with the temperature in metals. Okay, thank you.